find the table, right? Everybody can make the table. Find the frequency. Everything's good. Now, for your graphs, most of your graphs you can use the midpoint. I would suggest the midpoint. If you use the graphs for anything else, use their upper boundaries. And the ogive definitely needs an upper boundary. There might be a couple where you have to bring down like your frequency polygon. So you might have to just add another boundary to the left and to the right because you don't want to leave your graph hanging there. The frequency histogram, hint, hint, is a strong possibility. Okay, so just so that you can make a table, give me a basic graph, and whatnot. Now, on your graphs, remember, you need a title. You need to label your axes. Frequency. X is your minutes. This was minutes to do whatever they were doing here. Times to exercise. There's my title. I got 2 graphs on this, so go by the blue box first. This is your basic histogram. I use the midpoints. Make sure your midpoint falls in the middle. Make sure it falls in the middle of your box, your bar. Make sure your bars touch each other. There's no gaps in this bar, which is why we do a class boundary. Midpoint takes care of that because midpoint doesn't have an end. It just has the point in the middle. So our bars can touch. Your class boundaries took care of the gap between these guys. Between 136 and 137, there was a gap. We don't want a gap, so we expanded that and made your boundaries. Do your basic bars. Can everybody do that part? Basic histogram. Give me a title, label your axes, make sure that your graph, you'll have it'll be like a little piece of graph paper there. Make sure they're evenly spaced apart. That's another thing you can lose points for. You don't want to lose points on that. If you break the graph like it doesn't start at the 0, just make a little squiggle. So it didn't start at 0. The blue, again, is the frequency histogram. The red, that's your frequency polygon. Your frequency polygon says, take the midpoints of all of these, so therefore you have to use the midpoint, and just make me a line. Now normally my line would go here, 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 and stop. So I have to bring this down one more midpoint out. All I gotta do is take the class width and subtract it, and one more midpoint forward. Just take the class width and add it. Just so that you can bring it down to the lines. That gives you a frequency polygon. The rest of the information stays the same. Okay. Your relative frequency graph should look just like this one. The only difference is your y-axis. Your y-axis is your relative frequency. It's decimals. Remember to treat your decimals like money. So if I have to go from 0 to 50 cents, I went by 8 cents each, go by 5 cents each, whatever, go by 10 cents each, whatever you think you would like to do. Again, all you need is your midpoints. That bar graph should look exactly like this bar graph. Your relative, whenever it says histogram, it's a bar graph. Polygon, think of a polygon in math. A polygon is all different sizes, right? Shapes and sizes, how big you count the edges. So a polygon could be a triangle, a polygon could be a square, all multiple sides, right? So think of a line, segments. Just think of making lines to that. Anything with histogram has bars. The ogive is different. The ogive is a cumulative graph. That used to be your cumulative frequency graph. And your bars used to keep going up. But now, because this is mostly displayed in business, they like their ogive with a line segment. It kind of shows more steepness. Most of this is used for like sales growth and changes in something, changes in prices of gas, things like that. Changes in even price of eggs and things like that. They like the cumulative parts. Maybe my sales total, that would be better. Changes as a regular one, is a frequency polygon. But my total sales keep going up. They never go back down. They could stagnate. If you have no growth, it'll be a flatliner, but it will never go down. So if I had no growth from here to here, if I had a 0 in here, that would show me just a straight line, and then it would go back up again. So again, it shows a little bit of steepness in here. Use your end boundaries, your upper boundaries. You're going to have to start with your upper boundary, but you're going to have to drop it one lower boundary down, just so that it has a starting place. Don't end this guy. Leave this one right here. Leave it there. Are we okay with this? Questions? You probably won't see that one, but just to know it. Box and whisker. Can everybody do a box and whisker? How did we do the box and whisker? Find your Q1, your Q, find your 5 summary numbers. So you're going to take this whole thing and you're going to put this in your L1. This is going to go in your L1, this whole thing. You're going to do a 1-bear stack. And you're going to come down to the last 5 numbers. They're called your 5 summary numbers. So you're going to get a min, a quartile 1, a median, a quartile 2, a max. These are the 5 numbers you need to make your box and whisker graph. The median is the guy in the middle, right? So how much of your data does that cover? What percentage? 50. So doesn't that make sense? Sorry, this is your quartile 3. This is actually your quartile 2, 50 cents. Think of money. 25%, 25 cents in quarter 1. You did 25% of your data between the min and the quartile 1. 25% of your data between the quartile 1 and quartile 2. Okay? So you're going to make a number line, and you're going to put those 5 numbers on there. So when you come down here, you're going to take your 5 numbers. This was your min, your quartile 1, your median, your quartile 3, and your max. Make your number line on the bottom though. And then you can see, you can even look, say, oh, this guy could possibly be an outlier. It's kind of way away from this. We did an interquartile range. Interquartile range says take your 2 quarters that you get. You get quartile 3 and you get quartile 1 and subtract them. So if I wanted to do this, my interquartile range, 0.5 minus 117.5, I would find my interquartile range. That would tell me how much data actually fell in here, in the middle part. That's what your interquartile range tells you. Just be aware that you could separate these into 25% each. This guy right here, 25% of your data. 25%, 25%, 25%. So if we ask you, if we show you a box and whisker, and we ask you which one has the most consistency in the data, it would be the closer together. Which one has the least consistency, it would be the further apart. Spread apart more, right? Everybody can do this? Okay. All right. Circle graph. Circle graphs. We take all of your values and we represent it in a circle with percentages. So that these are used for, like, say your living expenses. 20% goes to food. 50-60% goes to rent. That'll be your big chunk. 10% goes to entertainment. The percentages don't change. The values will change as you get an increase. You'll put more in your savings. You'll put more to everything else because your rent will go up. So what you want to do is you want to take all these values, you want to add them up. Get a sum. And then to find your individual parts, it's part over whole. So it's 14.1 over 77.9. It's 32.1 over 77.9. That gives you percentages. Your circle graph has to have percents on it. Do not give me the values on there. All the percentages need to add up to what? 100. If they don't, Play with one of them. It's probably just the rounding. Sometimes you're rounding all up and then nobody got rounded down. Just play with the rounding a little bit. When you make your circle, easiest way is to section it by 25s. And then to say, okay, let me take one that's close. I got a 21.7, so slightly less than 25. I'm not measuring. So I write the name and the percent. Oops, this is 28% down here, sorry. And I write the percent, okay? So now I use 28%, maybe 13%, maybe 41. I want to go over here. 41 is close to 50, so it'll be about 9 away. This whole thing right in here is 41%. This is my recreational transportation, whatever that is. Okay, so now I've got 2 categories left, a 13 and an 18. The 18 is going to be bigger. Just make it a little bit bigger than the 13. This is 18%. This is 13%. Okay, as long as this makes sense to me. As long as my 41% is not the smallest and my 13% is the largest. So I'm not measuring these. I'm just eyeballing to make sure you have them where they should go. Do they have to be in a certain order on this circle? Not at all. Make sure you give it a title. A Pareto, this is a Pareto chart. Make sure you can identify this chart. Pareto goes from highest to lowest. It's like a frequency almost, but the x-axis has really no value of x values. So we just put our label, they're nominals. We put our labels down there, and our y values have the quantity values. So we label the bottom, and we put the frequency along the side. But it has to go from highest to lowest. A Pareto is nice because when you look at it, I say, okay, where am I spending my money? This is my highest expense. This is my next highest. This is my least highest. So maybe I want to address, why am I spending so much here and not so much here? I could see it in order. Good? No questions? Okay, and the last part, I know that was kind of thrown in here at the last part, but we just looked through your z-scores and we used your rule. Plus or minus 1, standard deviation, 68%. Plus or minus 2 standard deviations, 95%. Plus or minus 3 standard deviations, 99, 98, 9%, is that what we use? Okay, so kind of work those out. This is starting to use your z-score formula. I'll give you your formulas on your test, your z-score. I don't have any samples. There's no samples, so you can't divide by n. So it's just a regular standard deviation. Your plus or minus 1 says how much, what percent is between your plus or minus 1. So an easy way to do what prices are between your 95%. There's your plus or minus 2. Find out what 2 standard deviations below the mean is. Find out what 2 standard deviations above the mean is. I could easily take my 155 and say, take my standard deviation, multiply this by 2, and get 30,000. Then I could subtract 30,000, and then I could add 30,000. So it's going to go from here to here. Those are my prices. My chart is nice because it just gives me a visual. I like the graph because you put the mean in the middle, add your standard deviations up, subtract your standard deviations down. I just wanted you to find the z-scores using your z-score formula. Remember, we used plus or minus 2 to be unusual. We use plus or minus 3 to be very unusual. Because if you think about their curves, they're really, the curves go this way. We kind of exaggerate them, but they go this way. The plus or minus 3 are way, way, way out here. The plus or minus 2s are way out here, and the 1s are in here somewhere. But we exaggerate ours, and we make ours even. But they're a little bit more exaggerated. So the plus or minus 3 has very little percent there. You can tell by your table. If you look to the left of 3, it's really small percent. Questions at all? I wanted to hit 2 with you because 2 is the tougher one. Had a lot going on at the top. We didn't remember like the little details. But if you work on chapter 3 and chapter 4, tomorrow we can go over those. Well, chapter 3. Just do chapter 3 tomorrow. So you have plenty of time to work on it now. And then tomorrow we'll go over 3. We have fun. Wait. Perfect timing. So work on 3. Tomorrow we'll go over 3. We'll do 1 each day.